Eric Burgess here. Given the data, find the percentile rank of each value. And then we're given some data. Then it says also find the value that corresponds with the 60th percentile. So with this problem with percentiles, the first order of business is we have to have our stuff in order from lowest to highest. So let's go ahead and take care of that first. So our lowest value here is 230. And I'm going to cross that out. Up next, we have we do have a 400. We've got 489. After that, we've got 500s. So 524 looks to be the next lowest one. And then we've got 595. After that, 620. I take my time because it's super easy. Whoops, like right there, 658. To make a mistake here. Probably the number one mistake I see made is on this step, and it ruins the rest of the problem. 735 is our next one. And then we have 775. And 800. Okay, so we've got our percentile. We're in order now to compute the percentiles because we're now in order. So the percentile, the way we compute it, right, formula, the percentile is equal to number of values below x plus 0.5 divided by total number of values. Total number of values. And then at the end, we want it as a percentage. So we're going to do times 100. And we call this the percentile when we do this process to data that's been put in order from lowest to highest. And it basically lets us know where something is in a group. It's a measure of position. So what we're going to do now is we're just going to start plugging in. So we got to find it for each one of these. So we're going to do this process over and over. So I'm going to use the calculator to kind of speed it up, but I'm going to write out the first few so you see how it goes. So the number of values below x. So each one of these values is an x value. And the number of values below the first one, well, there's nothing below it, right? So we start off with 0 plus 0.5 divided by, and then the total number of values, which we have 1, 2, 3, 4, 5, 6, 7, 8, 9. We've got 9 values. And then we're going to multiply by 100. This will give us the percentile for 230, and then we're going to go to the next one. So now notice that we're just going to increase by 1. So we're just going to go up by 1 because now we're at this value. So there's one value below it, the 230. We're going to add 0.5, divide by 9, the total number of values, times 100. That's going to give us a number. Then we're going to go up to 2 times 0.5 divided by 9 times 100. Then you're going to go up to 3, up to 4, up to 5. This number right here just keeps going up by 1. It's the same formula over and over. And our last one, right, will be 1 less. Because at 800, well, the number of values below 800 is going to be 8. Because, right, 1, 2, 3, 4, 5, 6, 7, 8. So the biggest we're going to go up to is 8. So we start at 0, go to 8. And if you count 0 as 1, that's 9 values total. So let's go ahead and do this. I'm going to use the calculator. And what I like to do is use this fraction key. So I'm going to use the green key and then y equals F1. And we're going to go to the first option. And we're going to start out at 0 plus 0.5 over 9 times 100. So you'd have to enter this into your calculator a bunch of times. I'm going to make it so I only have to change the 0. So our first value is going to be, I'm going to write them over here, 5.55. We'll round to 2 decimal places. 56%. Up next, we're going to just copy it, increase it by 1. And we get 16.67%. Increase it by 1, so we're going to come up, copy it, increase it by 1 again, we're going to get 2. If you want to be really fancy, some calculators actually have a way to iterate through a certain number of times. but I'm not going to get that fancy on you. But if I was doing a lot of this, you better believe I'd find a way to make this automated because it would really stink to come in and do this every single time. So we're going to go to 3. Now we've got 38.89. I always forget the percentage. We're going up to 4. 4. And we get 50. Next, we're going to go on over to 5. And we get 61.11. So you see, this is actually it's an easy process. It's just, you just got to know how to set it up. Once you have it set up, you're gold. There's 5. So there's going to be, we're going to go up to 6. Now you might be wondering about that 0.5. I'll talk about that as soon as we're done here, because it's interesting. It helps with how many data points we have. 83.33. I didn't write the percentages. And then finally, our last one is 8. $94.44. So you notice that it doesn't go all the way up to 100%. It doesn't end at 0. It doesn't start at 0. And you might be going, that's kind of strange that it works this way. Part of the reason for this is that this 0.5, is an offset. So if we have very few number values, like 4 values, being first place, like let's say you run a race with 4 people and you're like a really slow person and you get 4th place. Well, they could also say that you were in the 25th percentile, right? Because the first person would be at 100%, the next would be 75, the next would be 50. So you'd be 25%. Like, it'd sound really good. Except for, that's a very low number of values. It's like the 100% is not super meaningful. Now, if you ran a race with 1 million people in it, all trying to win, and you got 4th, that's a lot more substantial, right? That's really significant. And think about it. This number down here would be 1 million. That million, this 0.5 is like nothing compared to 1 million. So it would be, the resolution would increase. That's why you see these numbers, they don't go all the way up or all the way down, is because this 0.5 is pretty big when you compare it to a small sample set like this, like only 9 values. It's not very big. But as the values, as we get more and more and more, this 0.5 is less and less significant. So this is sort of to account for when we have less numbers versus when we have a lot more numbers. Our measure of position gets a little more precise as we go. So let's go ahead and find the value that corresponds with the 60th percentile. So now we're kind of working backwards, right? So we were giving a number here. This number is kind of like a marker on where it was, like an index, right? So we started off at 1, 2, 3, 4. So we're going to get this index back and then look for the number that it goes with. Sometimes it's not directly in our set, so we have to calculate it. So we're going to say, okay, well, to get this number, we're going to call this number C for count. I don't know why they call it C. It's just called C. So we're going to have equals. So what we need is, well, let's say, okay, well, if we want this, we're going to need the total number of numbers, right? Because it's got to be somewhere in there. We're going to multiply it by the percentile. And then we're going to divide it by 100. So we're going to undo the percentile. So what we're doing is we're multiplying by a percentage. I'm just going to put MP. And then when we divide out by 100, we remove that percentage. And when we scale that against our number, we're going to get out the index, because that's basically what we're doing right here. We're just doing the opposite of this. Like, if we were to say number of values below X, we could call that C. So look at this. We have the percentile from up here. Percentile equals C, essentially plus 0.5 divided by n times 100, right? That's our formula. Well, let's just ignore this 0.5, right? Let's just call it c over n. That 0.5 is there for other reasons we already talked about. So what we do is, well, if we want to isolate p, we would multiply by n to both sides. So we'd get pn is equal to c times 100. And then, this is a times, we divide out by 100 and we get pn over 100 equals c. So that it literally just comes from the other formula. So if you have one of these formulas memorized and you know what the 0.5 means, you can literally just derive this. So that's what it is. And understanding that c is just a spot in our numbers. So we're going to get a value for c out. Now up here, all our c's, right? 4, 5, 6, 7, 8, 9. They all correspond to whole numbers. So if c is like a decimal, we're going to have to make a decision. And if c is a whole number, we're actually also still going to need to make a decision. So let's go ahead, let's plug this in. We're going to get c is equal to, our n is 9. Our percentile, they want the 60th percentile, right? That's what they ask, 60th percentile. So we're going to type in 60. And I tend to leave the 100 out and just type 0.6. You could do that, and then you wouldn't need to do this last part. But if you write the whole number in, you don't convert it, then you need this divide by 100. So, and this is something I see students confused. When they say percentile, just write the whole number in. Just use the formula if you didn't understand that last part. Yeah. So if you convert it, you don't need this 100 if you convert it to 0.6. But if you don't, you're going to need this. So we're going to come in here and we're going to do this thing. So we're going to do 9 times 60 divided by 100. We get out a decimal of 5.4. Now looking at this, 5.4, if we come up here, there is no index of 5.4. We've got 5 and we've got 6. Now consider this. If we go for 5, well, we're going to be below the 60th percentile. So we don't like that. We want the next number that's within it. So we're going to go up a number. We're going to round up to 6 so that we guarantee that we're corresponding with. We've got at least the 60th percentile. So we're going to go with c is equal to 6. That value is this one right here. So we would have the value 658. So that's how you find a specific data point that corresponds with a percentile. So if they said find the 70th percentile, we could do that. And that's why we do the rounding rule the way we do. Some people choose to interpret this error a bit different. So there'll actually be like other ways to do this. But in this class and in this book, that's how they want us to do it. We always round up. There's one other special case that I'm going to cover real quick. What if we had instead gotten out the value of 5? Well, if you get out the value of 5, you would think, oh, let's just go to the 5th value. But because of some of these complications that we talked about with the sample size and everything, and the measure of position getting more accurate as we put more and more numbers in, we account for that here as well. So if we get out 5, we actually take the 5th number and the next number after it. So we would go up to 6. We would take both those numbers. So we'd take 620 and 658. We'd add them together and then we would divide by 2. And that would give us the 60th percentile. So if you get out a whole number, there is a specific case that happens. So just so you know, if you ever see a percentile thing, whatever number you get out, you're going to be doing something with it. So just be aware of that. If you have any questions about this, feel free to drop a comment down below, subscribe and hit that bell icon for future videos, and we'll catch you in the next problem.